Our last topic on atomic structure is exponential decay. Now, exponential decay describes a process at which a quantity decreases at a rate proportional to its current amount. This is different from other decay rates that, for instance, are linear, where the amount that you decrease by is always the same. For instance, if you're thinking about numbers, you could start at 50, and if you decrease linearly at a rate of 5, then you would go from 50 to 45 to 40 to 35 to 30 each time you're decreasing by 5, regardless of your current amount. Exponential decay, again, decreases it at a rate proportional to its current amount. So an example would be decreasing by half each time. So let's say you start at 50, you would then decrease to 25, then 12.5, then 6.25. So each time you decrease, your rate changes depending on your current amount. Now, one of the measures for exponential decay is half-life. Half-life is the amount of time that it takes for a substance to decay to half of its original amount. Let's take a look at an example. So here we have a question that asks, how much of a 100-gram sample of radioactive 32-phosphate with a half-life of 14 days would remain after 56 days? This is a typical type of question you would see on an exam, and the easiest way to approach these half-life questions is to make a table. So what we're going to have on one side of the table for the columns is going to be the number of days that have elapsed. And then on the other, we're going to have the amount remaining. So this is almost like a T-chart. So to begin with, we can say that at first, 0 days have elapsed. So the amount that we should have remaining in grams is 100 grams. Then we can go ahead and allow one half-life to pass, or 14 days, and after 14 days have passed, that's a half-life, so we should lose half of our current amount, so now we should have 50 grams. If another 14 days passes, we lose 50% of that current amount, so now we have 25 grams left. And then if you continue on to 42 days, you'll lose half of that. So you'll be at 12.5 grams. And finally, 56 days is what we're looking for. So half of that will give you 6.25 grams. Now, if you actually do a plot of this, plotting on the x-axis the time that has elapsed, and on the y-axis the amount that you have remaining, you can plot this in a linear plot as shown, and you're going to see the typical exponential decay curve that you're used to seeing. Now, on this linear plot, both the x-axis and y-axis are on a linear scale. Sometimes on the MCAT, instead of giving you a linear plot, they will give you a semi-log plot. On a semi-log plot, the x-axis is going to be linear, but the y-axis is going to be logarithmic. And what's interesting is you can see on a logarithmic scale of exponential decay that the exponential decay curve becomes a linear line.